Okay, we're going to be continuing our work with graphing quadratic functions, and in this lesson our learning target says that I can identify the vertex of a quadratic function by looking at a graph, a table of values, or the vertex form of an equation. So again, today we're focusing on this word we introduced in the last lesson called the vertex, and we're going to try to find the vertex represented in 3 different ways. Let's start by looking at this do now, where it's asking us to compare the following 2 equations and their graphs. So looking at these 2 equations, I notice that they're written in 2 totally different forms. Our first equation here, this is written in standard form. This we're familiar with. We've been working with this for all of Unit 8. But now this second equation over here is written in a new form that we've never really seen before, with the parentheses and being squared. So let's take a look at what their graphs look like. So again, use one of the many methods we've talked about of graphing, and let's try to graph these 2. Okay, so here we have our first equation, y equals x squared minus 2x minus 3. Now we'll look at our second equation here, and we'll graph them at the same time. So you'll notice that even though these 2 equations look different, you'll notice that you only actually see one graph right here, and that's because these 2 graphs are actually exactly the same graph. They represent the exact same equation. If we were to FOIL out this second equation and then simplify, we would actually get the exact same as the first. So it turns out that these 2 equations are exactly the same. They look different. The first one over here, like we said, was written in standard form, and now the second one is written in a new form that we're about to be introduced to today, which is vertex form. Now, if we come back to our graph here, you'll notice that the graphs both have a vertex here of 1, -4. So that is something that they also have in common. Okay. So again, today we're going to be focusing on this key idea of vertex, and we're going to be looking at equations that are going to be written in this form right here, which is called our vertex form. So you should be going back into your packet about graphing quadratic equations. Today's lesson will be on page 3. So I'll give you a moment to pull that up. So as we mentioned in our last lesson, this keyword, the vertex, represents the turning point. It's either the highest or the lowest point. Whenever your graph sort of turns around, that is called the vertex. We've been working so far in Unit 8 with standard form, but like I mentioned in our do now, today we're going to be introduced to a new form which is called vertex form. And the reason why this is called vertex form is because it is super easy to pick out the vertex from this equation. You'll notice that we use some new letters here, A, H, and K. We're not going to worry about the A just yet in this lesson, but we're going to focus today on the H and the K because HK is actually going to represent our vertex. So if we have an equation in vertex form, it is super easy to pick out the vertex. If we take a look at our mini lesson, if we start with the equation in vertex form, we know that right here we have our H and we have our K. And if you notice in our equation, we have x minus h. So that means that our vertex is the opposite of the number inside of the parentheses, and then we have our k at the end. So in this case, the vertex would be +4, -17. So with our equation in vertex form, it was super easy just to pick out the vertex. Again, you take the opposite of the number inside the parentheses as your x value, and then the number at the end as your k is your y value. Let's take a look now at the table of values and the graph. So if we come back to the graph, we know that the vertex is the turning point of the graph, and I notice that this graph turns around right here. In this case, it represents the top or the maximum value. So to represent that point on our graph, we notice that that is the point 1, 6. So for our graph here, our vertex would be 1, 6. Finally, if we're looking at our table of values, we're going to be looking still for that idea of a turning point or something in the middle. Now, what I notice in my y values here, I see I have a 4 and a 4, a -5 and a -5. So I notice here that it is symmetrical about this point right here, which must mean that this is our vertex, because on either side of -8, I have -5 and -5, then I have 4 and 4. So I notice that symmetry around that middle point of 1, -8. So that must represent our vertex. So to take a look at our turn and talk question, how is finding the vertex different when represented in a graph, a table of values, and vertex form? Just to summarize what we just did, for our graph, we're going to be looking for either the highest or the lowest point, and that's going to represent our vertex on a graph. If we're looking at a table of values, again, we're going to be looking for this idea of symmetry. To be symmetrical means to be the same on both sides. And I noticed in the table it was symmetrical on either side of the point 1, -8. And finally, for vertex form, we can just compare this to what's written in our notes and try to identify our H and our K. So let's go ahead and try the guided practice. Please try to pause this video and then come back to check your work. So for the graph here, you should have identified the vertex as this point right here, and that is the point 1, -4. In this case, it represents a minimum value, but it still represents that turning point. In our table of values, again, I'm looking for symmetry. I notice a 2 and a 2, a -1 and a -1. So I notice that it's symmetrical about this point right here. So our vertex of the table of values would be -1, -2. And finally, for our vertex form at the end here, again, we're going to compare this to our equation in vertex form, which is a parentheses x minus h squared plus k, where the h and the k represent our vertex. So in this case, our h value would be 3, but again, we take the opposite of that number inside the parentheses. So our x value of the vertex would be -3. And then our k value, that constant at the end, would be 20. So our vertex here is -3, 20. Okay, so at this point, we're ready for our checkpoint questions. So please go to a loose leaf piece of paper. Your checkpoint is to do both of the following. They want you to identify the vertex of each. So identify the vertex of the table of values, then identify the vertex from the equation, and then come back here to check your answers. Okay, at this point, you should be listening if you have already tried these problems and you're ready to check your answers. For the table of values here, the vertex that you should have identified was this point right here, 1, -5, because I notice on either side I see a -2 and a 7. So the table of values is symmetrical around the point 1, -5. Looking at our equation here, I know that this is my h and this is my k in vertex form. We always take the opposite of h, so our x value would be 6 and our y value would be 4. So your two vertex should be 1, -5 and 6, 4. So let's reflect on how you did on this checkpoint question right now in order to do our independent practice. For independent practice here, you'll notice it says that if you were unable to identify either vertex, meaning both of them you answered incorrectly, please start with red. If you were able to identify one vertex, meaning you got one answer correct, please start in yellow. And if you were able to identify both vertices, please start in green. Again, we're looking for you to do at least one group's worth of practice, either red, yellow, or green, but it would be great to do more than one level of practice. Before you get into your practice, everyone should note for our extension problems down here that you can now do 4 more problems in your Unit 8 Regions packet. So go ahead and pause this video and come back when you're ready to check your answers. Okay, at this point you should be listening to the video only if you're ready to check your answers for your independent practice. Here is numbers 1 through 3 on page 4. Feel free to pause the video to check your work. Here's numbers 4 through 9 on page 4. Moving on to page 5, here's numbers 10 through 14. And moving to our last question, here's number 15 on page 5. So at this point in the lesson, if you still find yourself a little confused about how to identify the vertex, feel free to reach out to us for extra help. There's also some extra Khan Academy videos that were posted to help you out. Again, in order to get your classwork credit for this lesson, please make sure that you submit a picture of your checkpoint question as well as whatever independent practice problems that you completed. The last thing that we'd like you to do is go and find the first question on exit ticket 8.3. Again, you don't have to submit this question right now, but we suggest that you answer question number 1 because now you know how to answer that question.